Hello, welcome to Zigmatech Learning Hub. I will be your instructor for physics. For this class, we are going to be taking our exercises from Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell and get updated on new videos. Are you ready for this class? Okay, let's get started. Welcome to physics class, and today we are going to talk about equilibrium of bodies, or simply put, stability. Remember, we have done some topics on equilibrium of bodies, but today we want to focus on its stability. By the end of this lesson, you should be able to list the types of equilibrium, state the condition for stability, and define the center of gravity of an object, determine the center of gravity of objects. If you are ready, get your pen and let's get started. Look at the introduction and watch what is happening on the video, and this explains everything we are going to talk about in this topic. And if you look at that, the one at the left, you see the yellow ball rolling from one point to the other. We say that that kind of a body is a neutral equilibrium. That means for any little force you apply on it or displacement, it rolls on a table. Another one is the one with a glass of cup, the water bottle. When it was displaced, it came back to its original position and dangles, and then later stays strong. While the other one, when it was displaced with the red marker, it fell down. Now listen, the truth is, in physics, equilibrium is very important because there are so many things that don't need to move. For example, the building you are sitting, the building where you are staying now does not need to move. So it needs to be on equilibrium, and so many other things because of its importance. Because if it does, it leads to what we call collapse. So in this class, we are going to treat everything you need to know concerning the equilibrium of body and what affects their stability. Now, the types of equilibrium, just like you watched in the previous slide, we have stable equilibrium, unstable equilibrium, and neutral equilibrium. What makes this equilibrium to be what they are is what we are going to be looking at. Number one is stable equilibrium. We said that a body is said to be in stable equilibrium if it returns to its original position without toppling over or without toppling after being slightly displaced. That means, just like what happened here, watch here, you see, when this body was slightly displaced, look at this one, the water bottle, what happens? It will come back to its original position, even though there will be a little shaking, but at the end, it will stand strong. That is what we mean by stable equilibrium, and that is what we mean by if it returns to its original position without toppling. Without toppling means without falling down. We say that the body is in a stable equilibrium. Now look at the diagram also. This is the center of gravity of this body when it was pushed a little and then in different position. So the body is said to be in stable equilibrium. Now, we also have another example here. Look at this, another way of looking at a stable equilibrium. If you put this in a kind of a spherical, semi-spherical object or shape, it experiences a net force or torque in a direction opposite to the direction of the displacement. That means if I push this ball towards this direction, what will happen? There will be an opposite force, or should I call it a restoring force, that will bring it back to the center of this place. So we say that the body is in a stable equilibrium. However, on this stable equilibrium, you have to consider that when you push it, it will come back to its original position even at this point, which is called a spherical shape or object. Now, we want to look at the conditions for stability. Now, like we were talking about, I said so many things need to be in equilibrium. Even some moving objects can also be in equilibrium. That is when we want to talk about types of equilibrium in terms of force, which is dynamic and static. But then, looking at this car, you see, that is why some of these racing cars, all these racing cars, are very close to the ground. That is why it's difficult to fall. But when you see all those big lorries, long cars, any little displacement, it will just topple over and fall. But now, we want to look at the major reason why bodies can be in equilibrium. He said it has a low center of gravity. We are going to study what is center of gravity for you to know why a stable body has to be very center of gravity. Do you know of that your friend, very short, when you people are playing football, you push him, he doesn't fall easily? Like the so non-linear Messi, very short, very close to the ground. If you push him, many people, when he was very young, at his early 20s, he doesn't fall easily. Why? Because he has a center of gravity which is very low. Another one is that it has wider base. When the base of a body is wider, for example, the chair you have, when it is wider, the base is wider. What I mean by base is the place you use to balance it on the ground. That is the base. So the base is very wide. And number 3 is that when on tilting, center of gravity increases on tilting. So the center of gravity increases when you shift it. Tilting means when you displace it, when you force a little push on it. So these are the two conditions for a body to be in stable equilibrium. Now let's talk about the one we call unstable equilibrium. Now let's go back to the previous video that I showed you. Look at this one, or the far left right corner, the marker. Look at that. When it is pushed a little, what happens? Any little push you give to it, it falls. Very unstable, like anything. And then look at this kind of graph. Look at the position where it is at this point. When it was pushed, it fell down, comes back to this 0. All right? So from here, look at the graph, it falls down. But see this one, when you push it, it will go there. You see that? And increases, comes back to this point. So this is called unstable equilibrium. That means for any little push, it falls. If a body continues to move away from its original position after being displaced, for example, a little push, it falls down away from where it was staying, we say that the body is on unstable equilibrium. Yes. For example, a cone. That is a cone. Remember, when I say a cone, I have to say it very clearly. The cone must be standing by its tip. Let me look for a diagram that explains that. Okay, here, look at this cone. If the cone is standing at this point, look at the tip, the yellow one. You see, when it is resting at that point, even if it's possible, I don't know if that is possible, that is when we say that there is an unstable equilibrium. Another example is an egg on its apex. Remember an egg, the apex part of it. So, and then a very high car. I had that experience, a very high car. I mean, the tire is very high. Such cars fall easily for any little, especially on a very bad road. So another one is the ball resting on an inverted ball. Look at this one. The ball here at this point, when you keep this ball and push it a little, you know it must surely fall down to the end, to this path. Then we say that these are stable, unstable equilibrium. Now, what are those conditions for unstable equilibrium? One, it has a high center of gravity. The center of gravity is very high, and that makes it unstable. Narrow base. The base is very narrow, right? It doesn't balance. It doesn't have balance. Then, number 3 means on tilting, center of gravity decreases. When you tilt it, the center of gravity will reduce. Then the potential difference also does what? Reduce. Remember that potential difference is a function of height. Now let me show you something again. Look at this part. look at this part. This is the highest point. This is the zero end. So when you tilt it, what happens? The center of gravity will reduce and falls down to zero. All right? So that is it. From that red, look at that red dot. That red, can you see it? It falls down here. So that means the center of gravity decreases, and the potential difference also decreases, and the height decreases. All right. Let's talk about the last one, which is called neutral equilibrium. Neutral equilibrium. If a rolls and stays in its new position, if a body rolls and stays in its new position after being displaced. Example, a cone resting on its side. Look at this one. Is a ball on a smooth horizontal table, like this one. A body on it. Look at this one. A ball on a smooth horizontal table. You know what happens? It rolls for a little kick, like a ball. Just keep a ball on the table and push it a little. You know the ball will roll. It must be smooth. Why must it be smooth? In order to reduce friction. If the friction is high, you know that there will be no smooth movement for the body. So when such condition is met, we now say that the body is on neutral equilibrium. And look at the green cone is on neutral equilibrium. The body is going to roll for a slight displacement. Now, what are the conditions for neutral equilibrium? When displaced, its weight does not have a turning effect. You know, remember when I talked about moment of forces, there is something we call turning effect, a turning. So most of the times, the reason why stable and unstable has, you know, the reason why they shift in their position is that the moment about each turning point is restored is equal to the other one. That is why we have that stable equilibrium. But in this case, when displaced, the weight does not have any turning effect. And that is why the body continues rolling, moving away far from its original position. Number two, when displaced, the center of gravity and height above the ground remains unchanged. Let me show you. Let's get back to this. Look at the graph of the neutral equilibrium. Look at the position. See, there is no change in height. The same level it is at this point. There is no change in height. Now, when you watch this one, you see that the height changes. The height goes to this part and comes back. Look at it. Yes, the height has increased to this part. And when released, it comes back to this part and then goes a little. So there is a little change in height, but in neutral, there is no change in height. And that is why it behaves the way it does. All right. Now, let's talk a little about center of gravity and center of mass, because stability of a body, equilibrium, for a body to be in equilibrium, we need to consider what the center of gravity is all about. And people have this misconception about center of gravity and center of mass. They are not the same. The same way people have a misconception about weight and mass. Weight is not the same thing as mass. When we talk about weight, we are talking about mathematically the mass times acceleration due to gravity. But when we are talking about mass, mass is simply the content of the matter. Now, center of gravity is a point where all the weight, remember, all the weight in consideration with gravitational force, all the weight of the body of object may consider to act. That point where they are acting is said to be the center of gravity. Now, center of mass is the point where all the mass of an object may be considered to act. However, the similarity between these two is very negligible, but they are not the same. Now, look at this part. The mass of this man, of this boy at this left side, balances the one of this right side. And that is why this meter rule or this seat or whatever it is standing horizontally. And that means that the center of mass balanced the two. Now, if you look at the two boys here, the one on yellow cloth is having more mass or more weight than this one, and that is why he slightly depressed it towards his end, while this one is rising above. So these are the conditions, and this one is not in equilibrium. The center of mass is not balanced. If I shift this knife edge or turning point or the fulcrum to a little to this place, I may be able to balance it because it's a function of the weight and the mass from the turning point. If you don't understand what I'm explaining, you can now refer a little to the video we did on moment of forces, where you talk about the moment and the reason why these things are balanced. All right, now there are positions for a body to be in, for a body to balance. There are positions where the body must be for it to be able to balance. Now, there are some other understanding that say that a body must balance at a point or a line of asymmetry. And this diagram on the screen can explain better. If you don't know what I mean by body of symmetry, I mean that particular point on a body where you will cut it so that the body will be the same. That is what I mean. Now remember, human beings and some other bodies can never have a line of symmetry. There is no place you are going to cut a human being for it to, so that when you bring the two parts and join, they will be equal. No, we are talking about objects here, remember? So if you look at this object, this is a star, regularly shaped body, this is a star. At this point, if I put my pen at this point, then it will be rotating just like the fan. You know, the line where the fan is hung is the line of symmetry, all right? And then this one also a triangle. I know this must be the equilateral triangle. It has a body of symmetry at this point. So this is the point where the center of gravity is going to be positioned. So you have to memorize this. You know, at the center of a star, 1, 2, 3, 4, 5. The center of gravity is at the middle. For an equilateral triangle, the center of gravity is also at the middle, the point where the line of symmetry meets. Now, coming to another one, for other regularly shaped body like this one, like a square, the center of gravity is also at the point where the line of symmetry or the diagonals meet. And look at this one stated before. This is a circle and this is a ring, this is a disc at their middle. Also, the one that I didn't bring in this part is a meter rule, the normal meter rule. It's a uniform shaped body. Now, let me say this clearly. Every uniformly shaped bodies have the center of gravity at the middle. For example, a meter rule you use in your school of length 100 centimeter has a center of gravity at the middle, which is at the 50th mark. However, due to some mistakes made by the people who make these meter rules, they may not calculate it well. Sometimes the center of gravity is shifted to 49 or 52, as the case may be. But however, the point or the fact still remains the same. Now, when we talk about the center of gravity of an irregularly shaped object, we now use an activity called lamina and pendulum. Now activity find the center of gravity of a lamina, you know, of an irregularly shaped body like the scalene triangle, every other kind of triangle which is not equilateral. We now use another kind of approach to find where the center of gravity is. Number one thing you do is find the center of gravity of a lamina using a plumb line. Look at this plumb line, and that is this rope, this one, that is the plumb line. Number two, what do? Suspend the mass from 3 different places or vertices and trace the plumb line located. So when you do this, since the center of gravity will fall below the suspension point in order to reduce the moment from the object's weight, the center of gravity will be at the center of intersection of all the lines of plumb blade. Yes. So when you hang this at different positions and put this your line of plumb blade, the points of intersection of all of them is going to be the point where the center of gravity is going to be located for an irregularly shaped body. And that is the activity you can use to achieve that. Thank you. We have come to the end of this lesson. But remember, before we go, we have to go to Examguide app to look for more exercises as we prepare you for your exam for UTME, JAMB, and all the rest. Okay, you're welcome. We are now in the Examguide app, and this is UTME, the app for UTME. And let's get started. In this one, we are going to be having a few of these questions. Number one says, which of the following statement describes a body in a stable equilibrium? Number one, that is option A person walking on a straight rope. Did we see that kind of example? Some of these, the options are very funny. Never. A ball on a smooth horizontal table. No, we saw that example, but it's not part of it. A ball resting on an inverted hemispherical ball. A ball in a middle of a, this one is the option. Option D is the right option, because a ball in the middle of a hemispherical ball, that's correct. Then we said a cone is in unstable equilibrium, has its potential energy. Now, a cone in an unstable equilibrium has its potential energy. A, decreased. Now, you realize what we saw when we watched it. When you slightly displace the cone, what happens? A, decreased. B, increased, unchanged. Now, it can never be oscillating. Number one, it can never be unchanged. The battle is between decrease and increase. So the option is going to be decrease. Let's go to the next one. Okay. Another question relating to this topic is the diagram above that shows the position of a cone. The position which can be described as neutral equilibrium is it Z, is it X, Y, or Z? I am telling you it's going to be X. X only is the option. Another option is this: which of the following is in a state of unstable equilibrium? Which one? This is neutral, this is neutral, this is neutral. This one is unstable. Unstable equilibrium, this is going to be neutral. And this is going to be neutral, this is going to be. So the best option is option A. Unstable equilibrium, because for this one is going to roll over. Sorry, the option is option C, please. This is the option for a cone resting on its apex is an example of unstable equilibrium. Which of the following statements describe a body in a stable equilibrium? A person walking on, okay, we've taken this one before. Another question, which of the following objects is in a state of neutral equilibrium? This is neutral equilibrium is this one according to the options and the lesson. You can trace back to the lesson for more explanations. Which of these diagram below shows the position at which a small ball bearing is in neutral equilibrium? For a small ball bearing to be in a neutral equilibrium, it must be on a smooth horizontal table, and that is option D. Okay, look at this one. Scary, right? So we have to follow our principle. He said, the diagram above represents balls in an undulating surface, pardon. Which of the following options represent position of stable equilibrium? Position of stable equilibrium. At this one, I is this plan, this is this, okay. Now I'm going to tell you that the ones on stable equilibrium are the ones resting at the bottom. This and this, 1, 2, 3, and that option is option 3, option 6, and option 9. Which option gives us that 3 is here, 6 is here, 9 is here, and that is the right option. And look at this again. Which of the following bodies, each with center of gravity G, lying on a horizontal table, is or are in an unstable equilibrium? This cannot be on a stable equilibrium. For it to be on a stable equilibrium, the center of gravity needs to be very high. And look at this one, the center of gravity is high. For it, this one is a neutral equilibrium. This is a stable body. When I put something at this center, it will balance. It is only this one. This is the one. So I'm choosing 3, only option B. And finally, which of the following is a state of unstable equilibrium? Unstable, I'm choosing option C. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that makes learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that will benefit from it. Bye.